There and welcome. You should be on page 43 of your quarter 3 Algebra 1 notebook. We're going to work on factoring binomials. These are the try-it problems. So first things first, look for that GCF. If I look here at 4x squared plus 16, I see that 4 will go into both 4 and 16, no variable coefficient. So when I remove the 4 divided by 4 is 1, I have x squared, and 16 divided by 4 is 4. Now, I'm going to look, I've got a binomial, I'm looking for a difference of squares. I do have perfect squares, but this is addition. So this is not going to be a difference of squares. I cannot factor this anymore. Looking at my next example, I've got x to the fourth minus y to the fourth. There is no GCF for this particular binomial. Let's see if it's a difference of squares. Do I have perfect square coefficients, 1 and 1? I do. Do I have subtraction? Yes. And do I have even exponents? Yes. So this can be factored. I'm going to put x squared plus y squared, divided those into 2, and x squared minus minus y squared. Alrighty. So I feel pretty good about myself, except I do have to look, is there another difference of squares? Well, if I look here, I've got subtraction, even exponents, and perfect square coefficients. So I can factor my second binomial further into x plus y and x minus y. And now this binomial is completely factored. Looking at my next problem, I do not have a GCF. Do I have, let's see, it's a binomial. Is it a difference of squares? Perfect square, coefficient, perfect square. Even exponent, subtraction. We have got ourselves a difference of squares. So 9, the square root of 9 is 3, 2 divided x, square root of 5, 25 is 5, and then I'm going to have 3x minus 5. It does not look like I have a second difference of squares because I have odd exponents and, of course, non-perfect square coefficients. Looking at number 10, there is no GCF. I can see clearly no number or variable can be removed. And because this is addition, even though I have perfect square coefficients and an even exponent, this is addition. So it cannot be factored further. And this, for that reason, no GCF and cannot be factored as a difference of squares, is a prime binomial. Looking at number 11, I have a GCF of 3. 3 will go into 9 and 24. So I'm going to 9 divided by 3 is 3x squared. Negative 24 divided by 3 is negative 8. If I'm looking for difference of squares, I've got the subtraction and even exponents, but I do not have perfect square coefficients, so this cannot be simplified further. Okay, number 12. If I'm looking for a GCF, I actually know 16 goes into 16 and into 64. So my GCF is 16. 16 divided by 16 is 1, so I have x squared, and 64 divided by 16 is 64 divided by 16, is 4. So I'm going to subtract 4. Alrighty. So now, do I have perfect square coefficients? Yep, a 1 and a 4. Do I have even exponent? Yes. Do I have subtraction? Yes. This is a difference of squares. And I am going to simplify this. Square root of 4 is 2, so I've got x plus 2, x minus 2. Time for number 13. Looks like I can probably somehow take an even number, at least 2. I could take 3 out of both of them. 4 does not go into 42. How about 6? 6 goes into 42 and 6 goes into 12. I'm going to have that be my GCF. 12 divided by 6 is 2x, and 42 divided by 6 is 7y. There's no way to simplify that binomial further. Looking at GCF is 6. Looking at number 14, I know 4 goes into 4 and 24, and I also have at least x cubed that can be removed. So this has both a numerical and a variable GCF. So I am going to remove 4x cubed. 4 divided by 4 is 1, and 4 minus 3 is 1, so that leaves an x. 24 divided by 4 is 6, and 3 minus 3 is 0. And I can no longer factor that. It is fully factored. I can take an x out of here. 2 and 7 are prime, so there's nothing that can be removed. So x, 2 minus 1, I've got 2x. That's going to leave x to the 0 plus 7, and that is also fully complete. That's it for this video and try-its. Thank you.